All right, let's take a look now at number 6. All right, number 6, kind of the same way. We know all of our resistance values, but we don't know our amperage, right? So we got to just know how to figure out or how to simplify this problem. All right, what I'm going to do first is I'm going to look here and I'm going to say these two are in series over here in the corner. So I know that I can take these two and add them together. So I know in this leg right here, this leg of the parallel circuit, I'm going to have 14 ohms of resistance, right? Now I know that I can add, since they're in series, I can add this resistor to the total value of these resistances. But I don't know the total value of these resistances until I use that formula, that is RT is equal to R1 times R2 divided by R1 plus R2, and that's an X. All right, so let's take a look at that and say, basically we got 14 times 4 divided by 14 plus 4, right? All right, so 14 times 4 is going to give you 56, and that's going to be divided by 18. 56 divided by 18 is going to give you 3.11, and it repeats. We're going to round it off at 3.11. So that's my total resistance of this portion right here. We'll call this the A portion. We'll call this the B portion. So my total resistance here is 3.11. Okay. Now with 3.11 and 2, I'm going to get 5.11. Alright, for my total resistance. Alright, so if I'm using 5.1, and I look at these things and I say, well, the only one that's close is that 5.1. They just rounded off to one less point. So have I got 4.7 amperes? Well, I'll look at this and I'll say, well, I know my total voltage is 24 volts. Right? And right over here, I'll know here, if I take that and divide it by 5.1 ohms, I'm going to end up with, take 21 divided by 5.1, I'll end up with 4.7. And that's what I ended up with. So that would have been the answer for number 6.